Hello, Algebra 2. Sorry I couldn't be there today. Today's lesson is 5.7 in your notes. It's on operations and compositions of functions. We will have Tuesday for any questions and any extra help, and the notes key will be posted on Canvas after this video. So go ahead and go to the first part of your notes. We're starting with operations with functions. So basically you can add, subtract, multiply, and divide multiple functions at a time. So in the example they give us f of x equals 3x minus 7, and g of x equals 13 minus 2x. Find f of x plus g of x. So we're taking the f function plus the g function. That's all we're doing. The f function, so I'm writing it as f of x plus g of x. Under the f of x, I'm replacing it. It is 3x minus 7. That is what the f function is. Bring down my plus sign, and then now it says g of x. G of x is 13 minus 2x. Well, if we're adding two functions with x, then really all we're doing is combining like terms. 3x minus 2x, those are like, well that leaves 1x. Negative 7 plus 13, combine those, they're numbers by themselves, they're coefficients, or not coefficients, they're constants, that is positive 6. So that's all we're doing. We're going to simplify by using the operation to solve. So this first one is actually denoted as, instead of f function plus g function, they write it as f plus g in one set of parentheses. And they're both using the variable x. And we'll talk about why they have this x at the end in a little later. But for now, it's just saying we're taking the f function plus the g function. So that is called a sum. F plus g of x means the f function plus the g function. The difference would be subtraction. F minus g is in the first set of parentheses, then x. That just means I'm taking f function minus g function. Same process as above, except subtraction. Then we have product, so obviously multiplication. Again, f and g are being multiplied in the first set of parentheses, so that's how we know what operation we're doing. Times x, or of x, basically. And lastly, the quotient. F divided by g is in the first set of parentheses of x. So f of x divided by g of x. So we're going to break this down and see what it looks like and use it to help us solve and simplify. So go ahead and flip to your next slide and we'll get started. Alright, so example number 1, you're going to see me have to move some stuff in a second. So they give us, well, this is your f function. Then we have g of x, that g function, and h. The h function. Find each function, indicate any restrictions in the domain. It just means, is there anything the domain cannot be? That's what it's saying. So number 1, we're actually looking at f plus g. So we're taking the f function plus the g function. So we just literally write down whatever the f function is, and then I'm going to put plus, and then whatever the g function is. So my step 1 actually looks like, well, f is at the top x squared minus 8x plus 4. I put it in parentheses just to show, hey, that's all one thing. I bring down the plus sign because that's the operation we're doing, and then I write, instead of g of x, my g function, 4x minus 3. Since we're adding, those parentheses really don't matter. We're combining like terms. So really, our final answer, I'm going to write it in my felt pen real quick, is, well, final answer, we get x squared by itself, it doesn't have a buddy, negative 8x plus 4x. These two are like terms. We get negative 4x. And then positive 4 and negative 3 are like terms. 4 plus 3 is positive 1. So final answer, x squared minus 4x plus 1. Now the domain of this function, so the domain, again, is what kind of function does this make? That's kind of what we're thinking of. What can x not be? Since the leading coefficient, there is no value, but of that form in standard form, this is x to the second power. That means we have a parabola. Remember, a U shape. Any kind of parabola always has a domain of all real numbers. It goes forever to the left and forever to the right because it makes that smile, makes that U shape. Goes forever to the left, forever to the right. So the domain is all real numbers for any type of parabola. Same thing with anything to the third power, fourth power. Domain's always going to be all real numbers, so that's really, really nice. We're only having a couple of special cases, which I'll talk about here in a second. Alright, so example number 2, you're going to notice f minus h of x. So now we're taking f of x minus h of x. So I'm going to write down, well, what's the f of x function? Minus the h of x function. Now, those parentheses that I talked about are going to be really important here. Because, okay, we write down our f function, x squared minus 8x plus 4. Our operation is subtraction. When we write down h of x, if I did not have those parentheses, I would not remember that I need to distribute the negative. There are two things, a binomial. H of x is a binomial, it has two things. We have to distribute that. So really this is a negative x and a negative 2 in all reality. That's going to be important for whenever we go ahead and simplify. So our final answer in this case, combining again those like terms, well, nothing in the second set of parentheses has an x squared. So it doesn't have a buddy. So there's one of those. Now negative 8x, its buddy is negative x. We distributed that negative. Negative 8 minus 1 is negative 9x. And then lastly, 4. Its buddy is negative 2. We had to distribute. 4 minus 2 is, I'm sorry, that needs to be a positive 2. Is positive 2. 4 minus 2. So this answer, x squared minus 9x plus 2. Again, it makes a parabola, x squared, smiley face. That means the domain is all real numbers. Promise there'll be a special case here soon. Okay, number 3, they're switching it up on us. We're not even using the function f. This time we're taking h times g. So at the top, the function h, we're going to start with that one. And then it's going to be multiplied by the function g. So we replace the first thing. H is actually x plus 2, in parentheses, times g of x, 4x minus 3. Now remember, when we're multiplying, we're not finding like terms. This time, because we have a binomial times a binomial, we're going to be foiling. X times 4x is 4x squared. X times negative 3, that's negative 3x. 2 times 4x is positive 8x. And lastly, 2 times negative 3 is negative 6. So really, our final answer, we got to combine like terms. Final answer, 4x squared plus 5x, because negative 3 plus 8 is positive 5, and minus 6. There is our final answer. Technically, we do need an equal sign on each of those steps, so our final answer needs an equal sign. Otherwise, we need to rewrite this answer. So if we don't rewrite it, we want the equal sign each step that we use to simplify and solve. 4x squared plus 5x minus 6. Again, x is squared, a parabola, domain, all real numbers. Alrighty, keep moving on. Here we go. Number 4. F is being divided by h, so the function f is being divided. So this time, we write our function f on top of a fraction. And then we're going to write on bottom the function h. So our function f is x squared minus 8x plus 4. That's on top of our fraction. On bottom, well, h is actually just x plus 2. So really, if I wanted to, I could put parentheses here, do not have to. Since it's a binomial, it's already by itself. Now on top, x squared minus 8x plus 4. Well, that's really a trinomial. A equals 1. So we want to find the factors of 4 that add to equal negative 8. 4. 4 that adds to equal negative 8. Is there anything? Got 4 times 1, that equals 5. 2 times 2, that equals 4. Nothing that multiplies equal 4 will ever add to equal a negative 8. So this actually doesn't factor. It stays as x squared minus 8x plus 4. Oops, I forgot my plus. Let's fix that. Minus 8x plus 4. all over x plus 2. It does not simplify anymore. If you can factor it, try. This one did not. Okay, so because we couldn't factor anything out, here is our special case. Anytime we have a denominator with a variable involved. So our numerator is a parabola, it's x to the second, but because it's being divided by something with x, this actually isn't going to be a strict parabola shape. This denominator, just like in normal math, denominators cannot ever, we cannot divide in your calculator something that equals 0. So the denominator can't equal 0. X plus 2, whatever x is, cannot equal 0. So the one case we need to do is we set it equal to 0 and we solve. I subtract 2 to both sides. Basically we're saying x cannot equal negative 2. So whatever the denominator is, if we are dividing a function by a function, the denominator cannot equal 0 because we get an undefined function. You try to type in the calculator, I can't divide something by 0. So this is when our domain is special. X cannot equal, let me try that again, x cannot equal negative 2. That is what our domain is. That is called a restriction of the domain, which is what the directions are talking about. X cannot equal negative 2. This would be our restriction on the domain. Otherwise, we'd have an undefined function, which is something we cannot have. And we'll talk about that a little later as why. So most of the time your domain is going to be all real numbers. If you have a fraction, that's your special case. Okay, let's just try a couple more of these examples and we'll move on. So same thing, f, g, and h. Here's our functions at the top, just for reference. Indicate any restricted domains. So number 5, again we're dividing h divided by g. So we're taking the function h divided by the function g. Well, the function h is x plus 2. The function g is g of x, or 4x minus 3. Now, neither of these can factor. They're both x to the first power. So I can't take any factors out. So that means they're done. The only thing we have to be careful about is the domain of the denominator. 4x minus 3 cannot equal 0. We can't let that happen. So to get x by itself, to find out what is that number, we add 3 to both sides. 4x equals 3. And when we divide by 4, we learn that x cannot equal 3 over 4. Let's see if I can write that a little nicer, I'm sorry. Little screen, big finger. X cannot equal 3 divided by 4. So x can't equal 3/4 for our domain. Special case. Okay, last one of part 1. F times g of x. So we're taking the f function times the g function. Well, our x function is a trinomial, x squared minus 8x plus 4. And then it's times g, which is 4x minus 3. Okay, so this one's going to be special. When we multiply, we have a trinomial times a binomial. We got to multiply to each piece. So I'm taking 4x times x squared. 4x to the third. And then, oops, let me try that the other way. Since the binomials, the second one is just a little easier if I go that way. 4x times negative 8x. Negative 32x squared. 4x times 4, positive 16x. Same thing, I'm going to distribute negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times 8, positive 8, 16, 24 x. And then lastly, negative 3 times 4, negative 12. Sorry, that last one's an x. I can clean that up a little bit. That's an x. Sorry about that. Okay, so we simplify all together. Combine like terms. There's only one 4x to the third. Okay, I used to, I'm going to cross it out. Now, x squared, here's an x squared. Negative 32 and negative 3 make 35. Negative 35x squared. Great. 16 and 24. That makes 40x. Use those. And then minus